And welcome back. So now that we have the intro out of the way, in this video, Lee is going to get the project all set up.
Right. We're going to start off with a new project. As you can see, we've already started with it. We've created an empty project, created two folders, scenes and scripts. This is not going to be anything complicated. We're not even going to use the demo framework that we're using in the train demo for this one because actually we don't need it. We're just going to be experimenting with noise. And to experiment with noise, we're just going to need a texture. So I can go over here and create other. I'm not even going to create these pragmatically. I'm just going to drag or drop them into the scene. So we'll need a GUI texture. And I'm going to rename this one noise text, TX. And then I'm going to create a GUI text object and just name this debug text. So that will put our two objects into our world. I'm going to need a script, so I'm going to start off with a C# script. And I'm going to name this one MyRandom. You guys might recognize the name from somewhere. So, especially those that have just finished the other series of videos. Go ahead and sync the mono-develop project. And then open it up. And I'm going to go ahead and go through and basically kill everything. Now, we still have the project open from the last set, which is our random number R&D experiment. What I want to do is copy the entire MyRandom class that we've created here. So I'm going to copy it from this project, and I'm going to paste it here. So go through. I saw some red, so we need the system using. It looks like that's all of it. I can build it, make sure that there's no errors. I'm going to get rid of this one. So basically what we've done is we've transplanted the MyRandom class from our random R&D project into this project. I can also go ahead, we'll add a new item. This class will be our, just call it Game Manager, just to keep it consistent with the other things that I do. All right, now we'll need the Unity engine for using. Because this is going to be a mono behavior, we can't use the namespaces. So we'll get rid of that. We'll make this a public class. Whoa, that managed to delete everything. That was awesome. Let's try that again. So we'll make it a public class game manager, which will inherit from mono behavior. Go ahead and skeleton in a couple of things, which will be our void awake method. Our void start method. And our void update method. So those will handle the mono behavior stuff that we're going to need to rely on. I also want to make a private void update noise. So we'll put all of our update code inside of the update noise. Now we're going to need a couple of things to keep track of while we're doing this. We're going to need a timer, because we're going to want to eventually be animating our noise over time. So to do that, we don't want it to run at update speed, because it'll bog down the system, and it could quite possibly cause Unity to become unresponsive or crash and force us have to kill it and start over. So we'll make a constant float, and this will be our timer delay. And for now, we'll set it to half of a second. We'll make a timer. Now I'll just initialize that to 0. Inside of awake, see, well, let's make another one. I actually want to be able to hold a reference to our texture. So we'll go and set, see, how do I want to do this one? Let's go ahead and private texture 2D. So we'll call this one noise texture. Leave that for now. We'll also need a private game object. This will be our, I'm waiting, there it goes, little lag. Noise text object. So this is the going to hold the reference to our GUI texture that we've got in our scene. We'll have another game object. This will be our debug text. Also going to hold a reference to the game object in the scene. So inside of wake, we're going to set noise text object to equal game object dot find, and I named that noise text. Just make sure I've got the spelling on those right. They're capitalized, yeah, noise text and debug text. And I don't need this one anymore, so I can close that. Save some memory. I know your machine gets kind of tight on memory now. So debug text will be game object dot find and debug text. So that will take care of that one. Now inside of update, I want to take our timer, subtract our time dot delta time from it. If timer is, whoops. So if timer is less than equal to 0, we'll go ahead and do an update noise. And if we're running update noise, one of the last things that I want to do before we get out is going to take our timer and reset it to timer delay. So that will reset our timer. Now let's see, what else do I need to do inside of here? Now let's make another constant. So we'll make a private constant, whoops, integer, and this will be our texture size, and we'll set this for now to 256. Then what we need to do is initialize our noise texture. So noise texture is going to equal a new texture 2D. We're going to pass into it our texture size by texture size. And we're going to tell it to be of texture format RGB A32, because we will want to keep track of the alpha channel at some point. And we do not need to use MIP mapping for this one, so we'll set MIP mapping to false. So that will create our texture as well. Might as well go and fix our naming convention so it stops complaining. So all right, so I expect those for now. So that gives me all of this. So that works, that works, that works. Now let's go ahead and look at getting some information into that texture. So we'll start off by creating a structure to hold the information. So we'll create a var called data, and that's going to equal new color array, and this will be our texture size times our texture size. Whoops. And we'll need a pair of, or a nested array. So we'll start with
Nested array, nested loop.
Or sorry, nested loop. So we're going to go Y to texture size, and then inside of there, X again to texture size. Get rid of that one, get rid of that one. Now I'm going to set data, and I'll set data by going Y times our texture size plus X. And that'll be equal to a new color, and for our color I'm going to set, let's go with 1, 1, 1, 1. So I'm going to set it to pure white. Now let's make sure something else. Let's set it to just red. So 1, 0, 0, just in case. That way we know it's doing what it's supposed to do. Otherwise, if it's just white, it could accidentally have been white. But I just want to make sure. Now, to set our texture, we can do texture size. No, that's not going to be the right one. Where is, oh, I called it noise. Noise texture dot set pixels, not set pixel, we want set pixels. And then we're going to pass in our data, because that holds all of our information that we need. So we can pass that in. Now this will not get applied to our texture unless we tell noise texture dot apply, and this will apply the set pixel operation to it. Now if you forget this, this one is sometimes a hard one to figure out. You'll sometimes see what you think you're supposed to see. Sometimes you'll just see random noise. Sometimes you'll just see some lines and it won't really make sense what's going on. So if you put something in and you're not seeing what you think you should be seeing, it's probably because you forgot the apply for your texture. So now the other thing that we need to do is up here in awake. is to take our noise texture dot, let me see, noise texture dot, is it render? No. Trying to remember which one it is to get to it. Oh, noise text helps if you call the right object. So go to our GUI texture and then set our texture equal to texture or noise texture. Now this one, I'm kind of doing this one off the cuff, so I'm not sure if this works the same way as materials do. So this might work, this might not. The way materials work is it saves an instance. So I can say, tell the renderer's materials main texture to be set to texture. And every time I update this texture, every material that has it applied gets that changes. I'm not sure if GUI texture works that same way. I do know that if you were to take this line of code and put it inside your update here, it would guarantee to work. But if you did this with a material and you did the texture, it will cause your computer to crash. So because what is happening is it's constantly adding more and more textures to the materials, creating new instances, and the garbage disposal or the garbage collector in Unity does not deal with garbage collecting materials very well at all. And it's something that is known to crash Unity. So I'm gonna test it and see if it works. If it doesn't work, then I will move that line of code down into the update noise. But if it doesn't work, I'll move it. If it works fine, then we'll just leave it. But it's just something to know that if you're ever finding yourself assigning materials or textures to your materials or changing your materials, it's not something that you should be doing every frame. If you are, you're probably doing something that you shouldn't be. They should be assigned once, and then you can change your textures and their values later, but you don't constantly reassign textures into the materials because it works all on references. Just a little tidbit. So, all right, now, so that gets my texture, all that information. Build it, no errors. All right, now I can go over to here, take the game manager, I'm going to drag it onto the noise text so that doesn't give me any errors. Now I want to make some changes to our GUI texture. Now right now I've got it set to a 256 by 256 texture. So I want to move its X and Y to -128 and then set its width to 256 and its height to 256. I want to take my GUI text and take its Y offset. No, which way is which? So minus 400. All right, there we go. Let's turn this off and figure out what I'm doing with my GUI text. Keep forgetting I'm working with a much smaller screen.
Yeah.
Almost there. Okay. Normally, you wouldn't hard code or hard set this. You would set it up in code, and I might end up doing that before too long. But all right, so that gets my GUI text down there. All right, so now I've got that. Save it, run it, and I get a red square.
Perfect.
So that's plus. GUI text is not centered, so I'm going to adjust that. So alignment center, Anchor, I want upper center. There we go. So it should be nice and centered and look pretty. All right, now let's go back into here. And one of the things that I want to do is I want to do some timing. So what I want to do is check or start time and end time, and then get an elapsed time from that. So var start time equals date time dot now, and so that gives me that one. Var end time gives me date time dot now. Var elapsed time equals time span dot from. In this case, I'm thinking, I'll just do ticks just in case. I don't think it's going to be a big issue. But I'm going to take end time minus start time. And then I need to encase those in parentheses. And then I'm looking for ticks. So that'll give me my elapsed time in ticks. And up outside of the loop, var time is going to equal string.empty for now. And then here I'm going to set time equal to string.format. Oops, caps lock. And in here, let's do 0D2, and this will be seconds followed by 1D2, and this will be milliseconds. Now, if we start looking at times in minutes in our update, we've got a serious issue. So I'm not going to even look at that.
Right.
So then I'm going to take elapsed time dot seconds. Technically, I shouldn't even see anything in seconds, because if I start seeing stuff in seconds, we're still serious problems.
Right.
All right, so and I want to set the time from inside here. So technically, I could have put the time in here. So I will, because otherwise I won't have a time and I don't want it to update. So what I'll take is debug text dot GUI text dot text equals our time. So that should give us some time reporting now.
Cool.
So now we've got our updates are happening at 8 milliseconds. All right, now, so we've got a texture, we've got some timing code in there so we can compare stuff. Come on, there we go. All right, so we've got that. Now, let's try to get something other than just red. cool thing is we've got an interesting way that we can do this. So let's go var n equals myrandom dot hash 2d, and I can put in any seed I want, but we've been playing with 20, so I'm going to leave 20 in there. I'm going to pass in x, and I'm going to pass in y. And then I'm going to set our color to be n for all of the values. Now, hash 2d passes out a double, but our color expects a float. So I'm going to have to cast this down to a float. And we've designed all of our hashes and our random numbers to, by default, pass us out numbers in a range of 0 to 1. So we don't have to do any further conversions to make the color part of it work. So if everything works right, we should get something other than our red. And it kind of looks like white noise.
Mm-hmm.
So our hash, in effect, is really just a noise generator.
Mm-hmm.
So, and now if I wanted to change this up, now let's say I wanted to animate this noise over time, but I always wanted it to be the same. So I know my X and Y are going to come in based off of my textual coordinates here. 20 is my seed, so if I want the same noise to come in based off of X and Y, I do not want to change my seed. But I still want to be able to animate this. So what I can do is switch over to a hash 3D, and I can put in some other value here. So let's put in, let's say, I. And actually, I'll change that in a little bit. But I can come up here, create another variable or field, private. This will be a float, and let's just call it iteration. We'll set it to 0 to start with. Take this iteration, replace I here. This will be my iteration. And then after every successful update, in addition to updating the timer, I want to take my iteration and plus equal it by an amount. I'm just going to choose, say, 0.1f. This amount doesn't really matter. It will matter when we get into the more advanced noises, because then you'll see a nice smooth animation as the noise progresses. But because of the way the hashes work, these are just white noises. So we will get changes, but and I hit F5. We don't build Unity projects, if anybody saw that. But because we're in effect generating white noise, this is just going to look like static. It's not going to, it doesn't matter if I use 0.1 or 5,000. Our updates are still going to, should progress. Or am I not getting anything now?
I'm not seeing anything.
No, I'm not. So now let's see why we're not. All right. Noise 3D 20 iterations. I always gotta love it when stuff like this happens. We do these videos live.
There it goes.
Yep. Okay, so apparently 0.1 wasn't enough to cause it to make a change. But you can see we're at about 2.95 milliseconds. So we're roughly about a quarter of a second in the update, which means that I could probably push the update a little bit farther. I kind of like how it jumps, and sometimes it looks like a bigger jump, sometimes it looks like a smaller jump.
Mm-hmm.
Wonder if that's, oh, you know what it could be?
What's that?
Remember how we use the hash and we're doing the by 0.0001
Right.
multiplication? Wonder if that has effect on it.
No, that still looks pretty much the same.
Yep. And it's gonna because it's white noise. But I'm just wondering if, because we use 0.1, when you multiply 0.1 by 0.0001, we get a really small number.
Right.
So it might have been so small it wasn't picking it up. Just guessing. I'd have to play with it more. So let's go back to here. Let's try 0.2.
There it goes.
So it's, yeah. So it is animating.
Mm-hmm.
Now, let's see how fast I can make this thing go. So if I take our timer delay, nope, 1.1. So we're still at about the same. So it's almost like that's the fastest is we're already frame limited.
Oh, just so you know, because of lag, you're probably not seeing this, but it did speed up the.
Oh, did it?
Oh yeah, animation has gone up considerably.
Oh, okay. Well, then I'm just, yeah.
In
Well, I
fact,
am 700 miles away.
if you want to try to speed it up some more, like 0.05.
Because I'm looking at it, it's like it hasn't changed. It looks exactly the same.
Yeah, no, it's
Uh,
definitely sped up. Even our viewers may have difficulty because of the frame rate here in a second, but we'll see. But I can tell you if it does or does not speed it up.
yeah, I had completely forgotten about the team viewer part of it.
And that looks about as fast as it was a second ago.
Okay. Then we can see what it did to frame rate. I know responsiveness. Yeah, I'm down to three frames a second. So I'm definitely frame limited at this point. But when we were looking at the numbers, we already expected it because they were fairly slow.
Right.
So we don't want to be trying to run this at a real-time frame rates. It just is not going to cut it.
Mm-hmm.
But if you set it to 0.5, see, even then, we're crushing the processor at trying to do it twice a second. But we can kind of cheat and get almost like a little precursor of where we're going with this.
Mm-hmm.
Because the way noise works is a lot of people are used to seeing something like the cloud texture that you get out of Photoshop, or a lot of the Perlin noise, which is the nice little cloud, soft background with high frequency noise scattered throughout of it.
Mm-hmm.
And that isn't what you normally get out of any of these noise generators first time round. Because what you get is, in essence, what looks like white noise. But they apply a process of running several different passes, sampling the noise at different scales, and multiplying those or adding and averaging them together to get that effect. So what they're doing in effect is, if I take my texture size and reduce it down to 32 by 32, I'm only doing a texture of 32 by 32, but I'm still displaying it at 256 by 256. So what we get is something that looks smoother, like this. And if I go into this again, and let's say I drop it down to 4 and run this. So now we get something even smoother. So what happen, or what you do in real noise synthesis, is you'd run one pass sampling at a large scale, so you get something like this, and then you take something that's sampled at a higher res, and you blend those two together. And you do this usually, typically between 4 and 12 times are the numbers that I've run across for the number of octaves of noise that you do. So you would have, say, 8 octaves, where each octave goes up, your frequency goes down by half. So you end up with higher and higher, your noise becomes higher, well, by half. So your noise becomes less and less high frequency noise as time goes on, or you can reverse it and double your frequency each octave. But in effect, what you're trying to do is layer this blurrier texture with a higher texture each pass. And we'll get into that more as we get into value noise, and we'll see how that works. Because unfortunately, with the way our noise is set up, or what we're using, which is this hash 3D, we don't have the ability of really scaling our noise and getting information across it, because we're not using smooth sampling or gradient noise in the case of Perlin or Simplex. So we can't scale the noise. Whereas some of the other methods, what we could do is, if we wanted to decrease the frequency, we could take this, let's say, up to 48, and we could take our noise here and divide it in half. Let me put that back up to 256 as well, because I want to be able to compare to what people saw the very first time. So what you would expect by taking and dividing this by 2 is that our noise would be less frequency. We wouldn't have as many of those black and white dots. But if we run this, we get just as many black and white dots. It's still this real high frequency noise. With other noise algorithms, when we start doing that sample, or doing this divide by 2, what we'll in essence be seeing is if we did this instead. So we get less of the high frequency noise, and we gradually get smoother and smoother looking blocks. But with these hashes, we can't do it, which is why we're going to be getting into these different types of noises.
Cool.
So, and that's what we'll be starting off with the next video.
Okay, so does that pretty much cover everything that you wanted to get across in this video?
For the framework, yeah, it gives us the ability to put noise in, display it on the screen, and get some timing information back from it.
Awesome.
So it's pretty much what I wanted to show for this one.
All right, well, with that, that's going to conclude this video. Thanks a lot.